this fluctuation. This time the IC is in reboot mode. Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. In this session we are discussing how to troubleshoot a power supply which is using TNY274, TNY275, 276, 277, 278, 279, 280. It is TNY switch. Very simple IC, TNY276. Basically, one of my viewer is facing problem for TNY279 IC, and he is finding pin number 1 1.7 volt, pin number 2 5 volt. First of all, I am sorry that I cannot reply to each and every message for my viewers because I receive thousands message every day. So that is the reason most of the time it becomes difficult to reply all the comments. TNY276. It is exactly similar to 279. It is 8-pin IC. Pin 1 is enable pin. That is called feedback pin. Pin 2 is bypass pin or multifunction pin. Pin 4 is drain. Pin 5, 6, 7, 8. These are source pins. If we check block diagram, source pin is power MOSFET ground. Drain pin will go to transformer. Here is enable pin. That is feedback pin. Then there is bypass pin or multifunction pin. When this IC is connected in the circuit, drain pin, that is pin number 4, will go to the transformer. Transformer winding second end is connected to positive terminal of the main DC capacitor, smoothing capacitor. Positive voltage will reach to drain pin, and from its internal 5.85 volt regulator will provide charging current to the capacitor that is connected at bypass pin, that is VCC capacitor indeed. When this capacitor will charge at specific level, at that time this regulator circuit will be disconnected and this IC will start switching. Initially it will reach up to 6.4 volt. That is shunt regulator here inside. When capacitor is charged, then it will start switching until 4.8 volt. In that time, from 6.4 volt to 4.9 volt, if the IC will receive VCC voltage from auxiliary winding, that time it will work in smooth operation. Otherwise, it will go in off state and then it will wait until voltage at this pin will reach again at 6.4 volt, around 5.8 to 6.4 volt. That time it will start switching again. So that is called reboot mode. But if in that time the MOSFET start switching to this transformer, it will provide voltage here in the output. That time this circuit will provide biasing voltage, and to regulate voltage it will provide feedback. Its feedback circuit is very simple. When the output voltage are maintained here in the output, this optocoupler will switch and ground line will be connected to enable pin, and there is RCD snubber. Most of the time if we don't find voltage here in the output side, this snubber diode that is damaged. Sometimes there is RCD snubber and sometimes there is TVS based snubber. RCD and there is TVS diode. That time we need to check that diode as well. Sometimes there is line sense resistor that is connected between positive voltage and enable pin. That will sense the line voltage. This IC can be programmed in different ways. For under voltage detection, for over voltage detection, and multifunction pin can be programmed for different features. It is used in different power supply circuits, in computer power supplies, in TV power supplies, in different industrial power supplies. All these ICs are same, just only the difference is power rating. TNY274 is used for 8.5 watt, 275, 11.5, 276 15 watt, 277 18 watt, 278 21.5 watt, 279 25 watt, 280 28.5 watt. If we need 200 TNY275 and we cannot find this IC, we can use any of these numbers, higher numbers. Let's suppose I need 276, it is not available, I can use 279. All the voltage and everything is same, just only the power rating is different, that is power MOSFET. Switching frequency is same within this family, that is 132 kilohertz. Let's see this circuit configuration. TNY276 is used in standby section of this Delta Electronics 24 volt power supply. This family is widely used in computer power supply standby sections. Pin 1, that is enable pin. Pin 2 is bypass pin or VCC pin. Pin 4 is drive pin. It will drive this transformer, that is this standby transformer. There is RCD snubber that is connected in parallel to the transformer primary winding, and these pins are connected to ground pin of this capacitor, smoothing capacitor, this one. If you want to troubleshoot any circuit and we don't have that circuit diagram, it is a very simple and very useful method that we can use sample circuit that is most of the time provided in the data sheet of that IC. Let's suppose here is TNY278, but this sample circuit will applicable to all this family, 274, 280. Source pins are connected to this capacitor negative terminal, and this enable pin is connected to this optocoupler collector. Emitter of this optocoupler transistor is connected to this negative terminal. When this IC will provide switching, it will provide voltage in the secondary side. These voltage will be sensed from TL431. It will provide feedback. That time this ground level will be switched through this output transistor of optocoupler to the feedback pin, that is pin number 1. So pin number 1 is connected to this IC. In case we cannot find feedback, that time this IC will work in reboot mode. Its output voltage will fluctuate. Pin number 2 is VCC pin. VCC pin is connected to VCC capacitor, that is this one, 100 microfarad 25 volt. This is drain pin. Drain pin is connected to transformer this winding. So it will switch this negative line through here to this point. Here is diode between these 2 points. Diode, current limit resistor, these 2 capacitors, these 2 resistors, R, C, D, RCD snubber. If this diode is damaged or these capacitors are short circuited, that time this will not provide enough power in the output. That time the voltage will drop. This end is connected to this capacitor positive terminal, main DC capacitor. So transformer will receive positive voltage from here, and negative is connected at this point. This winding is auxiliary winding. These are 15 ohm resistors, this rectifier. It will provide voltage to this capacitor. Here is VCC capacitor, and here is switch. This switch will provide voltage to other chips when the voltage are maintained. Normally these voltage will reach to this pin. In the output side, there are multiple windings. One output, second output. These outputs are connected here, rectified from these rectifiers. one diode here, second diode here. These will provide voltage here. When these voltage are maintained here in the output side at these capacitors, that time it will provide feedback through this TL431. We will receive feedback here at this optocoupler. This optocoupler will switch that negative line to this ground. Let's apply power and we will check it now. If you don't have good experience in electronics, never repair it, because here are unisolated live voltage. Take care for the safety. Never touch any component when power is applied. Set multimeter to DC voltage. This is ground terminal. We will check voltage here. This is working power supply, 391 volt. Now first we will check voltage at pin number 2 of this IC. It is 6.2 volt. Normally 5.8 volt, 5.85 to 6.4 volt will available at this pin. 5.8 to 6.4 volt. It depends on the circuit. Maybe the same circuit, one IC will work at 5.8 volt, second is providing 6 volt, so it is working normally. If we have voltage on this pin, ground, and this pin from 5 volt to 6.2 volt, 6.3 volt, that means this IC is working normally. If we have fluctuation here, that time maybe we have something wrong in the output side. That time it is missing feedback. Connect to pin number 1 and ground. Normally 1 volt. This will be available at pin number 1. If we check its optocoupler, 1 volt. Input side. In the output side, same 1 volt. When it is receiving feedback, that time it will receive 1 volt. If 1 volt is present, that time the enable signal is working normally. That time the output circuit will switch. Now if we check in output side, we will check voltage across this rectifier. This one section 12.69, 12.6 volt. This circuit is now switching normally. Let's inject some fault here in the output side. When you want to work with circuit, always discharge the main capacitor, remove power and discharge it. Now I will make short circuit in any one section. Let's suppose this capacitor. That is between these 2 points. Now I will make jumper to this capacitor. So that this IC will now shift in reboot mode. Then there is this capacitor. If there is any component short circuit, sometime the capacitor is damaged, Schottky rectifier is damaged, that time this IC will work in reboot. DC voltage, a few millivolt across this rectifier. Also this rectifier. But if you will check at pin number 2, 5.7 volt. This IC is switching. Now if we check feedback, now it is 2.4 volt. That means there is short circuit in the secondary side. Now I created a fault condition that there is short circuit in the output side. On this rectifier, we will find some few millivolts. this fluctuation. This time the IC is in reboot mode. IC is switching, but it is in reboot mode. If you will check now its feedback pin, ground and pin number 1, here are 2.4 volt. That means this IC is now in disable state. It is not finding feedback, that its transistor is now in high conduction mode. Now check pin number 2, 5.7 volt. Now I will remove the fault condition. Now if there is no short circuit, the circuit is working normally, that time pin number 1 will around 1 volt. That is good working condition of this IC, that this optocoupler is now enabled. Pin 2 will around 5 volt to 6.4 volt, 6.3 volt, 6.2 volt, 5.8 volt, any working value that will indicate that this IC is working normally. We can also verify voltage across this RCD snubber diode, but if your multimeter is not good for AC response, for high frequency, never test it. Sometime if we check switching of this IC between ground and its drain pin, source and drain pin, sometime the multimeter will make short circuit and it will damage that IC, because its internal capacitance will provide switching. That time the IC may damage, our multimeter will make short circuit. We can damage any one of them if the multimeter has no good response. In this way we can verify the function of this IC using these two parameters. I hope you enjoyed this video. If it is good, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.